All right, so lesson 1-7. We've been working with greatest common factor and least common multiple. Today we're going to look at still using those, but now how can we apply them with word problems? So start off here with kickoff. Least common multiple of 16, 8, and 48. So a couple things we can look at is if we list these out, if we just look at 16 and 8, 16's first multiple will be 16, 8 obviously 8. The next one is 16. So between 8 and 16, 16 is the least common multiple. So whatever works for 16 is going to work for 8. So now if we look at just 16 then and 48. So first multiple of 48 is 48. So we'd have 16, then 32, and then 48. So 48 then is going to be the least common multiple, because whatever works for 16 is going to work for 8. Going to work the same thing over here. Now, the other way we've done this is with 8, 16, 48, where we do the prime factorization. So 8 would go to 2 and 4, which goes to 2 and 2. 16 is 4 and 4, which is 2 and 2, and 2 and 2. 48 then would be 6 and 8, which is 2 and 3, 2 and 4, which then goes to 2 and 2. So when it comes to prime factorization, you're going to start by what do they all have in common? Well, we have one set of 2's. We have a second set of 2's. We have a third set of 2's. So this one's completely done. So we're not going to worry about that one anymore. Now we're going to look at what do just these two have in common? Well, they have another set of 2's. This one here, all of them have been done. So the only thing that's left that we haven't done is this 3. So we take it times 3. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 3 is your 48. So either way, you're still going to get the right answer. Just keep in mind, listing works nice when you have smaller numbers. Bigger numbers, you're going to want to use the prime factorization method way. Either way are some things that you can do. So when it comes to word problems, a couple things you want to keep in mind. First off, you always want to read the entire word problem. Go through, read the problem out, and then we're going to start quantifying things. So first, go through, see what's even there. What are they having you do? What information do they give you? So then we're going to start going with, well, what do we know? We're going to write that down. So whatever information they give you, okay, there are 3 packs of bubble gum. Okay, we know we have 3 packs. Let's write that down. Okay, once we know once we find out what we know, then we're going to look at, well, what are we going to need to find? We're going to create that plan to what we need to solve. So we need to find how many total are there. So we're going to need to go through and we're going to multiply, or we're going to add, subtract, whatever. So we're going to make that plan to solve. And then we're going to go through, we're actually going to solve it, and then we need to look back, do we answer the questions what we solved, or do we need to do a little more? So if we look at, Neil here has 2 pieces of wire, one that's 18 foot long and the other one is 12 foot long. So we're going to have 18 foot and 12 foot. We know that, and I'm already making a mistake because I haven't read the whole thing. So Neil has 2 pieces of wire, one 18 foot long, the other is 12 foot long. If he wants to cut them up to produce many pieces of wire that are all of the same length with no wire left over, what is the greatest length in feet that he can make them? So we know we have 12 foot wire, 18 foot wire, and 12 foot wire. We're going to cut these up, and we want them all to be the same length so that we can not have any wire left over, but we have all of them that are the same distance here. So what are we going to need to find? Well, we need to find that greatest length. So right there is your clue word. Look for these clue words. A lot of times when we're dealing with greatest common factor, we're going to have that greatest, largest, what is the most. All of those are kind of some clue words to go, okay, that's greatest common factor. I need to find the greatest common factor of 18 and 12. So if we break up 18 and 12 to 2 and 9, 3 and 3, 12 would go to 3 and 4, 2 and 2. So greatest common factor, we're looking for what they have in common. we have a set of 2s, we have a set of 3s. And that's where we stop with greatest common factor. Greatest common factor is only what factors they have in common. So if we multiply this, we're going to get 6. And then we look at our question, okay. So if he wants to cut all of them to produce many pieces of wire that are all the same length with no wire left over, what is the greatest length in feet that he can make them? Have we answered that? For the most part, yes. Our greatest length is going to be 6. 6 what? With word problems, you're always going to have labels. Make sure you label. So 6 feet. From there, Amanda has collected 38 t-shirts and 30 buttons from her favorite band. She wants to combine them into an individual set to sell with no pieces left over. What is the greatest number of sets Amanda can make? Again, we have this clue word here, greatest. We know we're going to find the greatest common factor. So, what do we know? Well, we know we have 38 t-shirts and we have 30 buttons. 30 t-shirts, 30 buttons. We need to find the greatest common factor of the 38 and the 30. So, 38, if we break that up, is going to go to 2 and 19. 30, we could do 5 and 6, which go to 2 and 3. So greatest common factor of these is only going to be 2. That's the only thing they have in common. So greatest common factor of 2. What are we looking for? We're looking for sets. So 2 sets then is our label. So that would be the greatest common factor. So this isn't that we need to have an equal amount of t-shirts and an equal amount of buttons in each group. It's individually. So this group is going to have a set of t-shirts. This group will have a set of t-shirts. That first group will have a set of buttons. The second group will have a set of buttons. It's just as we break them up, each thing, so there'll be an even amount of t-shirts in each set, an even amount of buttons in each set. So that's where we get there. So, last problem here. Haley owns a business and assigns 2 of her employees to their shifts. She then assigns the first employee shifts in blocks of 21 hours, and she assigns the second worker shifts in blocks of 17 hours. If both workers must receive the same number of hours, what is the minimum number of hours that each one must be assigned? So, minimum. Now there's a keyword. So, keyword we're looking for here is least common multiple. Minimum, smallest, the least, all those lean towards least common multiple. They will also talk here of okay, we have sets of 21, blocks of 21. So we'll have groups of, if we're talking groups, we're going to be in groups of this. How do we make this the same? Again, same, another kind of keyword going with least common multiple. So, what do we know? Well, we know the one's going to be 21 hours. The other one's going to be 17 hours. So, we need to find the least common multiple. Now, working with bigger numbers, we could do multiples. That's going to go on for a while. So, what we're going to do is we're going to look at breaking these down. So, 21 would be 3 and 7. 17 is prime. If it's prime, we don't jump straight into just multiplying them out, but we're looking for, does this prime number have anything to do with what we broke this one down to? In this case, there's nothing that's the same from what we broke it down to with our prime. So then we're going to just straight up multiply those, and 21 times 17 is 357 hours. Again, need a label because of the word problem. So dealing with hours. So this is going to be the minimum. So after 357 hours, now they've worked the same amount of hours, even though they may work different amount of shifts, but then they're at least to the same total of hours based off of their shifts. So, any questions, let me know, and that's the lesson.